Welcome to Kenton's videos. Enjoy the video.
You want to jump right into building a neural network. First, make sure your environment has Python and NumPy. Once done, load a small labeled dataset and normalize features to mean 0 and unit variance. Next, design a minimal architecture. Input, one hidden layer, output. You should initialize weight matrices with small random values, 0, 0, 1 scale, and biases to 0 so gradients start sensible. Finally, vectorize inputs into batches and define shapes for every matrix, so your code runs without shape errors. Now implement the forward pass and loss so you can compute gradients. You should compute linear transforms z equals wx plus b, then apply activations like re-LU for hidden layers and softmax at the output. Use cross-entropy loss with the log sum exp trick to avoid overflow. Make your forward function return both activations and intermediate z-values because you will need them for derivatives. Once that works on a small batch, run a quick sanity check by comparing finite difference gradients to analytic gradients on one parameter. Finish by writing a training loop. Loop epochs, iterate minibatches, run forward, compute loss, backpropagate to get dw and db, then update parameters with sgd or atom. You should include a simple learning rate schedule, early stopping, and optional regularization like weight decay or dropout to prevent overfitting. Save model parameters to disk and evaluate on a holdout set while plotting loss and accuracy. Troubleshooting tip. If training diverges, reduce the learning rate by an order of magnitude and recheck gradient signs and initialization.
Thanks for watching. Consider subscribing if we helped you.